So we did this type already, but this was if you're solving for x and you have a log on both sides of the equal sign already, then you don't need to do anything fancy. You say, well, there's a log on both sides. So for these two sides to be equal, you just look at the arguments. So 3x minus 1 has to equal 4x. And then you just solve for x. But what's the only thing different about logs and square roots? What do we have to do with logs and square roots when solving for x? Check your answer. So is this the answer or is it not the answer? I feel like this is a question we already did, but maybe not. I have to check. So what was the rule? What was the domain of log? What won't work with a log? Negative. Just like a square root, you can't plug a negative in because they're powers. 2, 2 squared, 2 cubed. None of that will ever give you a negative. So can we plug in? So go back to your original question. 3, we have a minus 1. So that gives me minus 3 minus 1. Is that negative? I don't even need to worry about the other side. If one side doesn't work, it doesn't matter what's over here anyway, but both of them won't work. So, no. So, no solution. Okay. Okay, so what about this one? Same idea, there's a log on both sides. The log will always match, so you don't even need to say, what if the logs don't match? Because we don't go into that. And actually, you really never see that in any applications or anything. It's always the same log. So the logs match, so we just compare the arguments. So 6x minus 4x equals 2. And check your answer. So if we plug a 1 in, is that going to be positive? Yeah. And what about this side? Yeah. It doesn't mean, don't generalize and say, oh, if my answer is positive, it works, and if it's negative, it doesn't work. Don't generalize. You have to plug in and look. Because if this had been 6x minus 10, and we plug in a 1, will that work? Right? If that was 6x minus 10, and I plug in a 1, I would get 6 minus 10 is negative, and so it wouldn't work. So the answer being negative or positive doesn't matter. That's not what you're checking. You're checking if it works in the original. And to work in the original, it has to be positive in here when you plug it in. So that would be your solution. Okay? So that's just the easy one. There's a log on both sides. That's not normally what's going to happen. So we'll do the ones that aren't like that, right? So number 3. Should have started with this. Okay, so this does not have a log on both sides. So in order to solve, we have to do something to each side to get rid of the log. What do we do? We raise each side as an exponent base equal to 3. So why 3? It's a log base 3, so to cancel out a log base 3, you need a big 3. Yeah? What's that? Yeah, the inverse of log is a 3. Yeah, so or the inverse of a log 3 is a 3 to the power.
Okay.
So that's probably what you're thinking. Yeah?
Kind of like the box method, you know what I'm talking about when I say that?
3 to the negative 1 equals 3?
Yeah.
Yeah, you can do that. That's sort of just like we call that in math like a recipe. Here, do this and memorize what you do. Yeah. So this is actually what you're doing, and it gives you that as the answer. Yeah. So you can still do that if you have that memorized, but I think it's harder to say memorize this, memorize that, right? And then if you kind of memorize it wrong, you don't know the background to see what you're actually doing. If you guys don't know what I'm talking about or what she's talking about, don't worry about it. So these cancel, so this is 2x minus 1 equals 3 to the negative 1. What's 3 to the negative 1? It's a fraction, 1/3, right? Is any negative exponent? And then we solve it. So 2x equals 1/3 plus 1. This is back to chapter 1. 2x equals 1/3 plus 3/3, common denominator. And then you divide by 2, but there's a fraction on this side. So what do we call it instead? How do you get the 2 on the bottom of the other side? So this will be x equals 4 over 2 times 3. So 4 over 2. If you want to reduce that, that would be 2/3. So your question is what? Before we decide that's the answer, if there's a log in the original question, or square root, you have to check your answer. So was there a log in the original question? Yeah. So we go back all the way to the original before you changed it at all, and you want to check that answer. So if we check, so our original question was log base 3 of 2x minus 1. We want to put the 2/3 in there. We don't even care what it works out to be. You just want to see if it's positive. I mean, you can go through and calculate it if you want, but is this going to be positive? 4/3 minus 1, is that positive? Is 4/3 bigger than 1? Yeah, so it is. And I didn't worry about the other side because that didn't have a log in it. You just want to make sure that this is positive. So that being said, x equals 2/3. Here's the answer. So that's if we don't have a log on both sides. Now the argument doesn't have to be linear. It could be a quadratic or something. So this has a log only on one side. The base is what? 2. So you raise each side to the power of a base 2. So this would be log base 2 of x squared. Log base 2. Oh, sorry. 2 to the 3. 2 on both sides. And you're writing that whole thing as an exponent, right? So it should be a big 2 so that you can write that all as an exponent. So they cancel, and we get x squared equals 8. How do we solve that? X squared minus 8 equals 0. Difference of squares. What's the square root of 8? It doesn't work nice, so we just leave it that way. So x equals minus root 8. X equals plus root 8. Now, because this original question had a log, we have to check the answers. What do you think? Will they both work? Will one work? What do you think? Just looking at it. What is the argument up here? It's whatever is like comes after the log, like what's attached to the log. So the argument is x squared. Anything we plug in and square, isn't that going to be positive? Yeah. So both of them actually will work. Log 2 of minus root 8 squared. Root 8 squared is 8. And that's equal to 3, isn't it? Not that you have to do this part, but 8 is 2 cubed, those cancel, that's 3. And the same if we plug in just root 8 squared. 8. So what's the solution? X equals, you could say plus or minus root 8. Both of them work. Now going back up, so let's just make a note because I noticed some of you are doing this on the test. We have x squared equals 8. What's the other way to solve that not using difference of squares? Take the square root of both sides. I never really, like I said that with a cube. If we have x cubed equals 8, you take the cube root of both sides. We get x equals 2. I never did that for the squared, and there's a reason I didn't do that, which is what? Right. If you just take the square root of both sides, you get x equals root 8. It doesn't work, but what are you missing? The plus or minus. So in high school they told you whenever you take the square root of both sides, remember to put a plus or minus. And I don't really do it that way because people always forget the plus or minus and then they end up with half of the answers, not all of the answers. So that's why I keep doing difference of squares, even though you really don't need to. You can take the square root of both sides. It's just the problem is you have to put plus or minus, and if you don't, you're missing half the answers. Does that make sense? So you can do that. That's fine. If you never forget to put something down like plus or minus, you will not forget to do that, then go ahead, do it this way. But I noticed on the test a bunch of you did it that way. I didn't say to do it that way ever, but you did it that way because you've seen it before and you forgot the minus, so you did half the mark. Does that make sense? You got half the answers because you forget the plus or minus. And that's why I just never talk about that. But it does exist in the world. And it's how I would do it, but I wouldn't forget the plus or minus. But sometimes you guys would. Not always. Okay, this one I'm going to do two ways because I'm going to show you a log rule. So there's 3 log rules that are going to help us solve. So this one right now has a log on one side, but it's got a 2 in front of it, and that's a problem. Because whenever you're going to do something to both sides, you have to have just that function. You have to isolate like the cube root, or you have to isolate the absolute value. So anything in front of it has to go. So how do we deal with that first? What would we do? Right. Divide both sides by 2. So then we have log base 5 of 3x equals 3. Okay? Good enough. Now what? So it has a log only one side. You say, what's the base? 5. Put a big 5 on both sides. So 5 and this stuff as an exponent. They cancel. We have 3x equals 5 cubed. Doesn't work out nice, so we just leave it. Now, can we plug that into the original question and it works? You're only looking to make sure
Yeah.
it's not negative. There's no negatives in here anywhere, and that's not negative, so it's going to work. But was this the right check? Yeah, it was positive, so that's okay. So this is your solution. All right. Now let me tell you a log rule. Does anyone know it? When there's a number in front of a log, we can divide both sides by it, but what else could we do with it? Anyone remember? So, this is a rule. If there's a number in front of a log, it actually will work out to the same number as if we put that up as an exponent. Let me give you a really easy to see example. If I have 3 log base 5 of 5. Now, what's log base 5 of 5? Do you remember how to do log from last time? Yeah, maybe you know this one. Log base 5 of 25? 2. Why is it 2? Because any log, you say, okay, it's a base 5. How many times can I multiply 5 to get what number's there? So this would be 5 squared, so the answer is 2. I also said when you have the base matching this number, you can cancel, and that's the answer. What's the exponent here? 1. So, log base 5 of 5 is 1. So this is 3 times 1. Is that okay? Log base 5. Log base anything to the same base is equal to 1, always. So log base 5 of 5 is 1. Log base 3 of 3 is 1. Ln of e is 1, because that's a log base e. What's the other one that doesn't show the base? 10. So log 10 is 1. Right, the base is understood. So this is something that you should know. It's not really something to memorize because it's really just saying what's the exponent. The exponent's 1. So, okay. Now back up to our rule. So I wrote down 3 log base 5 of 5. If I use this rule, which says any number in front of the log, I can write up as an exponent, I could take that 3 and move it up to an exponent on 5. So that would look like log base 5 of 5 cubed. What's this equal? They match, so the answer is the exponent. 3. Doing it that way is 3, doing it this way is 3. What's log base 3 of 81? What do? You say 3 times 3 times 3 times 3. How many 3's multiply to give 81? 4. So the answer is 4. What if instead I said log base 3 of 81 is log base 3 of 3 to the 4, which is the same as putting the 4 in front. This is 4 times 1. Would we ever do that? Probably not, but it does work. Every time you can move the exponent up or down, it doesn't matter. Okay? So back to this one again. I divided both sides by 2 when we started last time. What if we moved it up as an exponent? What if I said, oh, I don't like that 2 in front, I'm gonna move it up as an exponent. This will actually make it harder, you're not gonna ever do this, but I wanna show you that it does give you the same answer. So here it is. Now what do you do? So there's a log, it's isolated, there's nothing in front of it, so we put a 5 on both sides. Raise that up as a power. So this cancels, we get 3x squared equals 5 to the 6th. Much bigger than the last time. Now how do we solve this? To do difference in squares, or square root if we remember to put the plus or minus. But what is this? This is 9x squared equals 5 to the 6th. I don't know what 5 to the 6th is, so let's just leave it like that. So this is x squared equals 5 to the 6th divided by 9, which is, you could use difference in squares. I'm just going to put this over. This is terrible. Now, is it the same answer as we got before? What answer did we get before? 125 over 3, which is 5 cubed over 3. Let's show if this is the same thing. Now, this is plus or minus, that's 2 answers, but what's going to happen when you check it? Is the negative one going to work? No, 3 times the negative number is negative, so the negative one won't work. So if you forgot the plus or minus, it doesn't matter. It's not an answer anyway. All right, so sometimes, and I'm showing you, you're not going to do this, but what happens is sometimes in logs, and when you get to calculus, I've seen this happen before, is you're checking your answers in the back of the book, because in your big calculus book they have the odd questions have answers in the back. So you check your answer and it's different than theirs. And then you come to whoever your prof is, so you come to me and you say, I got the wrong answer and I don't know what I did wrong. And what do I say? Well, if you simplified it, it actually is the right answer. Right? You just didn't simplify it enough. This happened a couple times in here. So let's just, as a review anyway, because we need to know how to simplify something like this. You can take the square root of 5 to the 6th, and you can take the square root of 9. So that's one thing with roots, you can split it up. What's the square root of 9? 3. What's the square root of 5 to the 6th? You don't need to work out 5 to the 6th to know this. It is 5 to the 3, why? What is their square root as a power? 1/2. So this is 5 to the 6th times 1/2, which is 5 to the 6th over 2. What's 6 over 2? 3. So it is the same answer you get. Now, you can always move that, whatever number it is, up into a power, but it actually makes the question more complicated than if you just divided both sides by that number. Okay, so I wouldn't normally do that, but I wanted to show you that it is a rule and it does work. So what's another rule of logs? So okay, as long as these are the same base, which they usually are in a question when there's more than one log. If we have 2 logs that are added, you can combine them to be 1 log by multiplying the argument. Or backwards. You can take, say, no, say we had this. This is kind of what happens in calculus, not really in here so much, but So we've got a 9 times x as the argument. You can split this up to be log base 3 of 9 plus, because they're multiplied, log base 3 of x. This doesn't have an answer unless we had something equal to, but what's this? What's 9? 3 squared? So this is 2 plus log base 3 of x. So you can start with something that's multiplied and split it up. That's what you're going to do in calculus. In this class, what we're doing is taking two separate and making them one. So for example, if we want to solve for x, and we have ln of x minus 1 plus ln of x plus 2 equals ln of 2x. So here it is. So the two types we've seen so far is if there's a log on both sides, you just compare the argument, or there's a log on one side and you raise them both as a power. This doesn't have either of those right now, but if you have two logs on one side, you can combine them using this rule. So do you see there's a plus sign in between? So you're going to use this rule, which says if there's a plus in between, whatever the argument is, you multiply it by whatever the argument is over here. So this is ln, 1 log, x minus 1 times x plus 2, all as one big argument, multiply. Now again, the square bracket doesn't mean anything fancy, it's just so that you can see that I want it to hold that all together. That's now the new argument of the ln. So now how do we solve this? A ln on both sides, so just compare the arguments. So you would say x minus 1 times x plus 2 equals 2x. How do you solve that? It's already factored over here, is that okay? Is the answer 1 or negative 2? No. The only time you can factor is if the other side is, what has to be on the other side before you use that factoring rule? A 0. So we need to expand this, bring it all to one side, and then factor. So expand that. So x squared plus 2x minus x minus 2. So don't get excited if something looks like it's already factored. It has to have an equal 0 on the other side before you factor. So this will be x squared plus x minus 2. Bring the 2x over. So x squared minus x minus 2. Compare the like terms. There we go. So now you can try to factor it. And it has to say equal 0 before you can factor. Now what if this doesn't factor? Quadratic equation. Does this one factor? Yes. So x is 2 or x is minus 1. Now what?
Check.
Check. Probably this one's not going to work, but. So x is 2. The first ln was that. Okay. And the rest are going to work. 2 plus 2. And 2 times 2. They're all positive, so that one's okay. The other, minus 1. So ln of minus 1 minus 1. No, and I don't need to check anything else. If it doesn't work in part of it, then it's not the solution. So that is not the solution. Now, what if the two logs that you have on one side have a minus sign in between? What do you think? What do you remember? The last rule. You divide. So if there's a plus in between, you add, or you multiply, and a minus in between, you divide. The divide ones are actually easier. You end up with a fraction, but to solve a fraction, you cross multiply. The other ones, you usually end up with a quadratic, and you might have to use a quadratic equation or factor, and I find those ones a little harder. These ones actually are easier to make up too. So let's do 2 examples. So log base 2 of 3x minus 1. There's kind of 2 different things I want to show you because people get messed up with the second one, not the same. So you say, okay, well, we've got an equation with logs in it. We need either a log on both sides so we can compare the arguments, or a log on one side so we can raise it to the power. Those are your 2 options. This has too many logs in it, so we need to combine them. So this has a negative sign, so you're going to use this rule. So you would say 1 log, and then write the big argument using the 2. So 3x minus 1 on top, and on the bottom x plus 1. Now we've got a log on both sides, so we can compare the arguments. So we have 3x minus 1 equals 5. And we don't have to factor this type unless it has an x squared in it. We cross multiply. So 3x minus 1 equals 5 onto x plus 1. So there's only one option for a solution. Probably not going to work, but let's check it. So the first log was 3 times minus 3 minus 1. Is that going to be negative? And why am I not plugging it into the whole thing? The whole first, you always go back to the original. How come I didn't plug it into the whole thing when I checked it? As soon as you get a part that doesn't work, you can stop, because if it doesn't work in one of the logs, it won't work in the question overall. You don't need to keep checking, right? So I just checked in this first one, and I got a negative inside, so I knew that didn't work. If I put it in here as well, I'll get a negative, so that won't work. There's nowhere to plug it in. Okay, so that's 1, and I said I do 2. So the second one looks like this. So this one doesn't have that log on the other side, it's just a number. So a bit harder. Which rule does this use, the multiply or the divide one? There's 2 logs, and what's in between them? Plus. So why am I saying this is example 2 of the divide type? You see that's a minus? When you're adding two things, they both are positive, that's the multiply one. These are actually being subtracted. If I said, for example, so 5 plus 3 is 8, you add those numbers, right? 5 minus 3 is 2, you subtract those numbers. Minus 3 plus 5. You subtract the numbers. That's subtract. That's the exact same question as this. Not the normal way we put it, but it could happen. And so this is also 2. This is a subtract question. So you have to be careful. Does that make sense? So you're not looking for the sign in between the two. That's not what you're doing. You're actually looking to see, are the two logs added or are they subtracted? So if one of them has a negative sign, you're actually subtracting. Which one would go on the bottom? The first one, because you're subtracting that one. Right? This is the same as saying log base 4 of 2x plus 3 minus log base 4 of x plus 1. You see it? That's the same thing as subtract question, so it's divide. You write log base 4, great big argument. On the top is the positive one, and on the bottom is the one you're subtracting. Make sense? So whatever one is negative is the one that goes on the bottom. It's your subtract. Okay? Now what do we do? Yeah, it doesn't have a log, so you can't compare the exponents. What do you raise both to a 4? So this is kind of strange to write because that's big, but that whole thing is the exponent, so I wrote it kind of small. So you take you raise both sides to the power base 4. These cancel, so we have 2x plus 3. It's no longer an exponent once they cancel. 4 cubed is what? 4 times 4 times 4? 64. Cross multiply? Interesting. Is this going to work in the original? It's negative, so my first thought is, I'm going to have to check for sure because it's probably not going to work. Is this smaller or bigger than 1? Let's guess what it's equal to so we can plug it in easy without a common denominator.
Smaller.
It's smaller than 1, right? Because 62 over 62 would be 1. So this is like, let's say, what are we going to guess? Sure, 0.9. It's pretty close, right? It's only 1/64th away. That's really small, so 0.9. If we plug 0.9 into the first one, negative 0.9, sorry, plus 1. Is that positive or negative? Positive. What about here? That's a bit trickier. What would 2 times 0.9 be? Think about change. If you had 90 cents and you doubled that, how much would it be? $1.80. Right? 2 times 90 cents is $1.80. Think about money sometimes. If you have decimals, sometimes that will help. Is that going to be positive or negative?
Positive.
Positive. So it actually will work in both. So don't say 0.9 is the answer, because that was my guess. You could do a common denominator, but if you're just checking, you know, if you can get something close, then that's your answer. That's it for logs.